Energy levels generally increase as the principal quantum number n increases, though sublevel energies can overlap, so a higher n sublevel sometimes lies lower in energy than a lower n sublevel. Think of electron shells like stairs. Each higher shell number n is a step that is usually higher in energy, so electrons on those steps have more energy. Within each step, there are smaller platforms called sublevels like S, P, D, and F. And those platforms can sit at slightly different heights. Sometimes a platform on the fourth step can be lower than a platform on the third step, which is why 4s can be lower than 3d. The exact heights depend on how strongly the nucleus pulls the electrons and how the electrons push on each other, so atoms with more electrons show more mixing and exceptions. When chemists say energy increases with n, they mean the general trend, but real atoms show these overlaps because sublevels are not perfectly separated by n alone. Students often think that all electrons with the same shell number n always have higher energy than any electron in a lower shell. But the 4s versus 3d case proves that wrong, so check sublevel ordering rather than only n. Another common mistake is assuming the same ordering for every element. Remember that electron-electron interactions and nuclear charge change the relative energies across the periodic table, so use observed configurations for tricky cases. A quick tip is to learn the usual filling order as a guide, but verify exceptions by consulting actual electron configurations. For more videos and resources on how energy levels and sublevels work, check out www.gumballdegree.com.